video, we are talking about the rate of the diffusion of a gas, the various formulas you can use to calculate question or rate the diffusion of a gas, and the calculation aspect. So what I want to do, make sure you stick to the end of this video, make sure you have to prepare a notebook to take down every single thing. Now let's get started. When you talk about the rate of the diffusion of a gas, it simply means how fast a gas will escape from a container through an opening. Now consider this container here, and we have gases there, right? Now here we have what? Now an opening here. So these gases are looking for ways to escape from this container. So if I have an opening here, now the rate at which gas will escape through this container is called the rate of diffusion of a gas. Diffusion is also the same thing as effusion. There are two things use interchangeably. Do you get that? So now if you now compare N2 and O2. Now one thing you want to understand is that the rate of diffusion of a gas depends on the weight of that gas. Now heavy gases diffuse slower compared to lighter gases. Now consider for example here we have two guys in a race and one weight is higher than the other one. Now let us say we have a slim guy and a fat guy. Now you agree with me that the slim guy will move faster than the fat guy, right? The same thing with gas here. So light gas diffuse faster than heavy gases. And how do you know the one that is heavier and light? It's true that molar mass of that gas. Molar mass is the molar weight of the gas, right? So if you should calculate the molecular weight of nitrogen, of course it's going to be 14 times 2, which is 8 gram per mole. Then you look at O2, you're going to be 60 times 2, which is 32 gram per mole. Now through this value here, now the lower this value, the higher the rate of diffusion of a gas. So if you should not compare these two things here, it means that N2 will diffuse faster than O2. So that's why we say that the rate of diffusion of a gas is inversely proportional to the square root of its molar mass of that gas. So light gases diffuse faster or move faster than heavy gases. So you see the kind of question in your job, so please take note of it. I look at various formulas, do you get that, and the definitions. So the first one is the relation between rate and the molar mass. Yes, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass of that gas. So if you look at it very well, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. You get, so if you should remove this sign of this sign here we have rate is equal to 1 over K over square root of N. So if you should cross multiply here we have rate square root of molar mass of the gas equals to K. So now let's say we have rate 1, rate 2, rate 2, right? So here we have rate 1, the square root of molar mass of the first gas. That is the rate of the first gas, the square root of molar mass of the first gas is equal to rate of the second gas, square root of molar mass of square root of second square root of molar mass of the second gas. So if you should arrange it very well, here we are going to have rate 1 over rate 2 equals to square root of molar mass of gas 2 over square root of molar mass of molar mass of gas 1. You get, so now if you should cross multiply, I'm going to get this one back. So this is one of the formula you are going to use. Now let me just say here we have the gas is x and y. So if you want to substitute here we have rate x over rate y equals square root of y over rate square root of molar mass of x. Do you get that? So it means that if you must take note of this one here. That one is the first one here. So this is the relationship between rate and molar mass of the gas, right? Now, the rate of a gas also depends on the density of what of that gas. So we have what we call the rate of the diffusion of a gas is what inversely proportional to what the square root of it is what density. So now I go to the definition here. We have the rate is inversely proportional to what the square root of what is what density. Just like for what for the molar mass. That the higher what density, the lower what the rate of that gas. The lower the density, the higher what the rate of what of that gas, right? So if you remove this sign here, we have rate is equals to what k by what square root of what of the gas, right? Square root of the density of the gas, right? So if you should cross multiply here, we have rate times this square root of density of the gas equals to what k. Do you get that? So if you should involve two gases here, we have rate of the gas of the first gas times the square root of the square root of what density of what of the first gas equals to what the rate of what of the second gas times the square of the density of what of the second what gas. So if you arrange very well here, we now have what rate 1 over what rate 2 equals to what the square root of the density of what of the second gas over what square root of the density of what first gas. So imagine if you have x and y as well as the gases. So you go to do what rate x over what rate what y equals to what the square root of density of what of y over what square root of density of what of x. So this one looks so much like what on the first one we have done. So taking up this one here, do you get that? So now let's take the what first question using those formulas, those two simple formulas brought to you. Now look at the first question here. Now the rate of effusion of argon gas was measured to be what 0.218 mole per second. So the rate of argon given is what 0.218. Now let's leave the in first, right? Now at a constant temperature, calculate the rate of effusion of what helium. So you have been asked to calculate the rate of what effusion of what helium. You get. So now they went ahead to what give what the molar mass of argon. So here we have molar mass of what argon to be what 40, right? We were gram per mole. The molar mass of what helium is what 40. No, is what 4, right? So it means that I want to use what now the two guys what argon and what helium. This formula here we have rate argon over what rate what helium because what the square root of what. Remember the molar mass of what helium now come to the top. Molar mass of helium will come to the top over what the molar mass of what argon. You get. So this is the formula I was using. So before we solve this question very well, now what I want to know is that anyone can be at the top, anyone can be at the down. So if my rate of helium be at the top, then it will be at the down, right? When you come to the down, then it will be at the top. So whichever one you want to use, you get to also arrive at the same answer. So now let's substitute our values now. Remember, I look for the rate of what helium, right? Now the rate of argon is already what 0.218. So here we have what 0.218 over what rate of what helium equals to. Now the molar mass of helium is what 4 over what the molar mass of argon is what 40. Usually what 40. And when you divide from here we have 0.218 over what rate of what helium equals to what. Now 4 divided by 40 here we have square root of what 0.1. You get. So if you should make sure inside the formula here, I want to cross multiply, right? So when you cross remember yes all equals to 1, right? So when you cross multiply, what are you going to get? Here we have what rate helium times what square root of what 0.1 equals to what 0.218 times 1, right? Divide both sides by what rate of what 0. Now square root of what 0.1 square root of what 0.1, right? So rate of helium is going to be what? 0.218 divided by square root of 0.1. 0.218 divided by what? Square root of 0.1. Here we have what? Here we have 0.69. So this is the answer here. So what is unit? Remember, unit is what? Mole per what? Seconds. You get. So this is what you want to take note of here. So now this is what the first question. So now let's look at what the second question. The second question is a little bit tricky, so I would like you to pay very close attention. Unknown gas has a rate of diffusion that is 4 times faster than what? Oxygen gas. Determine the diffusion of the gas. So now these are the what possible gas: hydrogen gas, helium gas, carbon dioxide, and what? Carbon monoxide. You get. So I got to do this stuff here. Now the easiest way to solve this thing is to look for the molar mass of the gas. So the molar mass of the gas that equals to the molar mass of any of these gas will not be that gas you get. Now let's look at the statement again. Then an unknown gas has a rate of diffusion. So now let the unknown gas be what? X. So then the rate of what? Of the unknown gas is 4 times faster than what? Oxygen gas. So it's going to be what? 4 times faster than what? The rate of what? Rate of diffusion of oxygen of the gas. This is what the statement here, which also is stated as what? 4 rate of what? Oxygen of gas. You get. Now, but if you look at the question very well, now the rate of oxygen gas was not given to us, right? So you can see that let rate of diffusion of what? Oxygen gas equals to what? 1 mole per what? Seconds. Now, another means tell the word pick 2 or 3, right? But now let us pick 1 here. Now, if here is 1, if the rate of what? Oxygen gas is what? 1, the rate of diffusion of oxygen gas is 1, that is the rate of what? The unknown gas is going to be what? 4 times 1, which is what? 4 mole per what? Seconds, right? Now the easiest way to do it is to calculate what? The molar mass of what? Of the gas. Which is what? Molar mass of what? X. We don't know. You get. Now the molar mass of oxygen here, of oxygen gas, going to be what? 60 times 2, which is what? 32 gram per mole. You get 32 what? Gram per what? Mole. Do you get that? And let's use our formula here. So if you should use rate 1 over what? Rate 2, that is the rate of what? First gas over what? The rate of the second gas equals to what? Or square with what? Molar mass of what? Second gas over what? Molar mass of what? Of the first what? Gas. You get. So we are going to use this formula here. So what are we going to do here? Now remember the first gas is what? X. So now you're going to do what? Rate X over what? Rate O2. It's what? O2, which is what? Oxygen equals to what? Or square root of what? Molar mass of what? O2 over what? Molar mass of what? X. So what I have to do was substitute what our values and look for what? Molar mass of what? Of the what? Of the X. So if we substitute our value here, so remember this one is what? 4, right? It's 4. Rate of X is what? 4. So it's going to be 4 over what? 1, because the rate of oxygen gas is what? 1 equals to what? Or square root here. This one is what? 32 over what? M what? X. So what I want to do now, I want to remove this square root here. So we want to what? Square both sides. Do that. If you square both sides, you're going to do what? 4 raised by 2, because 4 divided by 1 is what? 4 here. What's what? Now if you square this one here, you're going to remove what? The square root. So it's going to be what? 32 over what? M what? X, right? So if you do it very well, 4 raised by 2 is what? 16, because 4 times 4 is what? 16 equals to what? 32 over what? M what? X. Making a cell formula here, going to be what? When you cross multiply, right? M X equals to what? 32 over what? 16. We're going to give what? 2. Which is what? 2, right? So we're going to be what? 2 gram per what? Per mole. Actually, what the gas with the molar mass of 2 is going to be what hydrogen, because hydrogen is the gas that have what 2 and what molar mass. So the identity of the gas is what H what 2, because 1 times 2 is going to be what 2 gram per what per mole. So this is what the answer. So these are the what possible ways you can what solve question what rate of diffusion of what of a gas. We have come to the end of this video here, but I want to leave you with a question you can easily do follow what we have done in this class here. I would like to solve this one. Please leave your answer at the comment section. Now this one is a typical Jamb question. Do you get that? So leave your answer in the comment section, then I will see who gets the answer. Do you get that? So if you are not subscribed to the channel, please hit the subscribe button, turn on the notification bell, because you don't want to miss out my next upload. Do you get that? So see you in the next video.